Hello, my name is Zachary Chenoweth, and this is my presentation of Lab 2, Task 4, the Bug Zero algorithm. For this task, we have to have our ePuck robot use the Bug Zero algorithm to get from its starting position to our desired goal. Here we have the controller. We have all of our initializations for the robot. We have our distance sensors, the camera, the IMU unit, and then the motors for the robot. Here we have some of our constants, which are Cmax, Cmin, which is the maximum and minimum velocities that the robot can travel. We have our Kp value, which is the proportional gain, which we're going to use for the PID calculations in order to calculate the velocity we want to set the robot to. And then we have our RT, which is our desired distance from the front wall. Here we have our F saturation function, which is used in the PID calculation. All this function does is basically cap the velocity that we calculate to the max and minimum velocities, so it cannot go above or below, and it has to be within that range. Here we have the forward velocity function. This function basically calculates the forward velocity using PID. It uses the current distance to calculate the error. From the error, we go ahead and multiply that by the Kp value, saturate it, and then convert it to radians per second, and then set our wheels to that velocity. Here we have the corners function. What this function does is it gets the robot, when it's following the wall, to go around the corners, such as this one here or this one here, where when the robot comes out, the forward distance sensor and then the right distance sensor doesn't read a wall. And basically all this function does is that if it's facing, because of how the obstacles are set up, if it's facing one cardinal direction, then we want to turn it so that way it's facing the next cardinal direction. So if it's facing south, we want it to face west. If it's facing west, north, north to the east, east to the south, and so on and so forth. These values are based off of the IMU units here, here, and here. Normally, it would just be -90, 180, 90, and 0. All of these are in degrees, but sometimes the IMU value will read 180 degrees as -180. So we have to account for that by placing this if statement here. So basically how this whole function works is that it will move the robot forward for for about a second or so, just so that way it clears this wall and gives it enough time so it doesn't run into this wall when it turns. Then we're going to go ahead and turn and then move the robot forward so that way the right distance sensor gets onto the wall before it gives control back over to the wall following function. This function is the turn 90 degrees function. This basically will be the function we use to get out of these inner corners here. So if the robot comes into here and it sees that it has a wall in it to the front of it and to the right of it, it's going to want to turn 90 degrees to the left. And that's what this function does here. Here we have a turn left function, and basically what this does is, let's say that the robot is going to go ahead and when it's heading towards the goal, it hits this wall. We need it to turn left so that way the right distance sensor is on the wall. So what this function does is it basically gets it so that way the robot will face the wall so that way the wall following program can take over and follow the wall as it needs. This function face object is for when we're in the motion to goal state, and basically all this does is if the object, in this case this yellow cylinder, is recognized by the camera, then it's going to go ahead and center the camera onto this object. And that's all this function does, is it's to center the cylinder in the camera. The motion to goal function basically will move the robot towards the goal. The wall following function is what we use to follow the walls. And here we have several states. The first state is that if our C value, which is our right distance sensor, is less than 7, meaning that it detects a wall on its right side, and it does not detect a wall on its left side. I'm sorry, the wall in front. So it has a wall on its right, but not a wall in front. Then we want to go ahead and just move forward. So for example, if the robot was here, it detects a wall on its right and not one in its front, so it's just going to want to move forward. Here we have the next situation where it detects a wall on its right and it's forward. So if it's stuck in a corner like this, then we want to go ahead and get the robot close to the wall, depending on the PID calculations we did before, and then turn 90 degrees. So turn out of the corner and then move forward. The next one is if we have no walls on either the right or in front. So those would be the corner cases. Then we want to call our corner function that I mentioned earlier. And then finally, we have the situation where it doesn't detect a wall on the right, but there is a wall in front. So if it hits the wall straight on and it doesn't detect one on the right, then we want to go ahead and turn left and get the forward velocity to make the robot move. Here in our main while loop, we have all of our distance sensor readings as well as the camera get recognition number of objects. So because there's only one object in our world, this function can only return 0 or 1, depending on if it sees the object or not. And then we have our IMU reading, which we print these values in 4 decimal precision. Here we have an if statement, and it's going to execute this whole line of code if the object is recognized. So if the camera sees the object, we're going to run through this line of code. And all this lines of code basically say is that, well, if we're close to a wall and it happens to be the goal, so if we're right up against the cylinder, then we're going to go ahead and stop and say goal reached and break from the loop, ending the program. Otherwise, we're going to go ahead and stop the robot and then turn on wall following, so it starts following the wall. So this is for the cases when it hits a wall, and when it sees the wall in the forward direction. Else, if the left distance sensor is triggered, meaning that there's a wall on its left side, we want to go ahead and turn it so that way the wall following can take over. And this part is here just for the situations where, like, let's say for example, the robot starts here and it's angling itself towards the goal. Because we only have 3 distance sensors, if for some reason the angle that it's approaching this obstacle isn't triggering this distance sensor, we're using the left distance sensor to detect this obstacle right here so it doesn't run into the wall. And that's basically what this stretch of code here is doing, is it's detecting this wall and is going to turn the robot so that way the wall following kicks in and then following the wall as it goes. Next is the right distance sensor, and this is sort of similar. Basically, if we have a situation where we're angling towards this and it detects the wall here, but the front distance sensor for whatever reason doesn't see it, then we are aware of this wall. And then this section of code also prevents it. So like, let's say, for example, the robot is moving forward along this wall. Because the robot can see the object, it's going to be tempted to want to face the object and go that way. But because this wall is here, we don't want it to do that. So this section of code prevents it from doing that by making it go forward until it's free to be able to move towards the goal. Here we if the number of recognition objects is 1, then we have to motion towards the goal. If there's nothing blocking the robot, we want to move towards the goal. Otherwise, if the object is not recognized, meaning that the camera does not see this object, then we want to wall follow. And that's the basic controller. Now, before I start the controller, I'm going to quickly explain what the Bug0 algorithm does, just so we see what the behavior is like. So the Bug0 algorithm basically says if there's nothing in the way of the robot, move towards the goal to contact with an obstacle. Once it comes into contact with an obstacle, you're going to turn only left or only right, depending on what you choose, but you can only make left turns or only make right turns, depending on your controller. My controller basically only does left turns, so it will only choose left turns. Then it's going to go ahead and follow the wall that it's next to. So it's going to follow this path until it sees the object again. If it sees the object again, if it's up against this wall, it's going to continue to follow this wall until it hits a leave point where the robot isn't blocked by anything, and is going to head towards the goal again until it either reaches the goal or it hits another object. If it hits another obstacle, then it's going to turn left, align with the wall follow until it's free again to move towards the goal. And then once it gets to the goal, then the program ends. So now that I explained that, let's go ahead and see it run. So as you can see, the robots are moving towards the goal. It hits an object, so we want to turn left and follow the wall. So now we're in the wall following state where it's going to just follow these obstacles until it can see the object again. So as you can see, it can see the object, but there's this wall here, so it doesn't move towards the goal until it gets to this leave point, then angles towards the goal and then heads towards it until it hits this object. And now it's wall following again. Now this section right here is a bit strange, so I had to account for the fact that because it can't see the object when it gets to here, it's going to turn this corner. So right now it's in the corner function that we defined earlier, and it's not until it gets to here when it's free from that it can move towards the goal. And then once it gets to the goal, it stops about 2 inches away from the wall, thus ending the program. Let's go ahead and see this run from a different spot. So let's go ahead and put our little bug or robot right here and see what it does. So it's going to angle towards the goal. It's going to sense this wall and turn away from the wall, follow this, and then it's going to motion following the bug algorithm as before. And then the program ends. Go ahead and see it run one more time. This time we're going to go ahead and put the bug, let's say about right here. So this is going to be its starting position. So as you can see, it's going to angle towards the goal and head towards it. But the left distance sensor is going to sense this wall and it's going to turn. And now the wall following kicked in. So now it's going to put the right distance sensor against the wall and it's going to follow this wall. It's going to turn the corners and it's just doing the wall following because it can't see the object. In this box up here, we can see the camera that the robot is using, so we can see what the robot sees as it's making this motion. And as you can see, when I had it go on the corners, I made it turn slower, so that way the IMU has enough time to read the correct values, because if it's going too fast, it's not going to read as accurately. And then it moves towards the goal, and thus the program ends. Now, there will be some situations where if the robot goes into an obstacle region where it can't get out because it's only making left turns, like say for instance, if the robot found its way into this little corridor right here, it's going to get stuck in an infinite loop or break the program because it doesn't know where it's going, and it's just stuck. That is my Lab 2 Task 4 Bug Zero algorithm. Once again, this is Zachary Chenoweth, and I hope you have a wonderful rest of your day.